So without further ado, let's welcome Anna and Árpád into the stage, where they're going to have a beautiful time talking to you about agile development.
Let's start with you guys. So hands up if you work at Automotive.
Okay, hands up if you work in an agile environment.
Okay, and hands up if you would like to buy a car that drives itself. Brave guys. Okay.
All right, so thank you for introducing yourselves. Let us do the same for you. So first of all, we have Árpád Maróti here today, or as I like to call him, the architect. He's one of our wonderful system architects at Automated Parking.
And here we have Anna Moró. She's a release train engineer. Sorry, I missed the slide. So she's a release train engineer, and if you don't know what is a release train engineer, she's the Scrum Master of Scrum Master in our organization. So if you are fighting Scrum Masters, she's the boss fight. And so, as you already know, we came from Continental, which is not a hotel chain, obviously, and not only a tire manufacturer. So here at Continental, we produce everything for automotive, starting from rubber tubes all the way up to automated driving solutions. And we came from an AI development center located at Budapest, which is a development center that is currently hiring, and we are building up a great team who we work on automated driving solutions using AI, and with AI, we will be able to save lives on the roads. But in this talk, we will discuss a little bit about ADAS, so Advanced Driving Assistance Systems, which is a name for all the automated driving solutions we develop. And the software development is going through a change. And this change involves going from the classical development into Agile. And in this talk, we are going to present you why we think Agile is the good way of automated driving development. We will discuss the problems and challenges we have, for example, with demoing our solutions, and also the challenges for architecture, the challenges with coming up a great Agile process for this work, and the challenges of building up a good organization.
Okay, so if you ever think about automotive software development, probably the first thing that comes into your mind is waterfall development. If you don't know what waterfall is, it's a very linear way of project management. You get tens and thousands of requirements from your customer. They want you to design a system for it. They want you to implement it, test it, and then basically you're done. They also want it before a fixed release date, but we somehow found that this is not really working for us anymore. Let's find out why.
And in order to know why or how advanced driving development became like this, you have to know the history of those developments. And historically, the automated driving components were sold as components, as hardware components. You could just buy them off the shelf, install it into your vehicle, and you would have the functionality. For example, you could buy a Continental Radar. This is a hardware block that can run an embedded software that does the automated driving for you. So another example could be the gearboxes we had. So if you buy a gearbox driver or a gearbox control from Continental, it works with that hardware only. And what is needed for automated driving? So just an example, because I work at parking, will be a parking solution. So here you could have a vehicle. For parking, you need to have some sensors. So for example, you need to have ultrasonic sensors installed to your vehicle. Next to them, you will need to have cameras, because cameras will be able to see the markers on the ground, which is a really important thing for parking. You should also know your current velocity, your current heading. So you need something like an inertial measurement unit that will tell your current motion state to your system. And since you want to do automated parking, you have to be able to control the vehicle, which means that you need something like a motion control component. And in between all of these, you need something like a control unit that can run the software for you. So as you can see, this is a complex system, and we need complex solutions for them. But what do we deliver to our customers? How the market is working right now? Here, the component business that I explained is still alive and well. So the car manufacturers, we at Continental create different hardware components such as radars, cameras, and everything that is needed for automated driving, and we sell them separately. And our customers are interested in buying those components separately because they don't want to buy a whole system at once, because it means that they would be somehow under a monopoly of one of the suppliers. So they want to build their solutions from piece to piece, coming from different suppliers. But next to this component business, we have the software solution business emerging, which means that we want to sell our software for automated driving as a product, which means that for this product, we will have some requirements. For example, they should be able to run on different kinds of hardware, even hardware that is not manufactured by us. So this is something that drives the complexity of those software solutions. But the main takeaway that according to the current business trends, the software and the hardware business is not coupled anymore. So we have the component business and we have the software solution business living next to each other. And what does it mean for the software solution development? We have two sides. The first side is requirements. Since we are working on a software solution, it is really, really important for us to be able to sell it more than once. Because if we can sell it to multiple customers, it means that we get more profit out of our current development. So this is something that is a requirement for our solution. Next to it, since we want to sell it to multiple customers, they will have slightly different requirements towards us. It means that our software has to care about multiple inputs from different corporations, but also we have to care about what to think about the future, what will be required by our future customers. And this is also a hard thing. And next to these, so according to these all inputs, our architecture should be configurable and scalable, because I know that some of our customers will want to have a low-endish basic solution, and some of our customers will want a high-endish solution. And we want to support them with the same software system. What happens on the technical side? So the technical side is also challenging, because automated driving is a complex problem. You cannot really enumerate all the kind of parking slots in the world. You cannot really tell all the kind of traffic situations on a highway. So this is an open world problem. And for this open world problem, we are working on a solution. And we have different technologies coming into this field. For example, AI is getting more and more into our systems. It gets into our cameras, it gets into our radars, and beside that, we still have the old rules from the past. For example, our functional safety standard, the ISO 26262, doesn't really discuss anything about AI. And so the process is behind technologies. And what do you think? How should we develop in an environment that has these kind of constraints?
In order to use this decision, here you can see the Stacy matrix. On the y-axis, you can see the requirements scaled from known to unknown, and on the x-axis, you can see the technological realization, also scaled from known to unknown. As we have discussed earlier, the requirements are quite well known, even in the beginning. So we are somewhere here. I don't know if you can see that, probably not. So we are somewhere here in the bottom part of this picture. But as Arpi has already mentioned, the technological realization is still quite unclear. So if you want us to be marked on the map, we would be somewhere here, deep in the complex space. It tells us that we should go into the agile direction rather than the previously mentioned waterfall direction. But will Agile really solve all of our issues? What can we really do with it?
I think not out of the box. So when we are talking about Agile, the main value of Agile is customer collaboration. So this is something that is very important. And since we are working on a complex systems, it can be really hard to collaborate with the customer, because we want to somehow show our current progress and get feedback from the customer. So in this chapter, I will talk a little bit about demoing our solutions and what difficulties does it have. And it is also very important because in the current business situation, even us from Continental couldn't really just walk into our customer and say, okay, hi, we have this great solution, please buy it. And they would never buy it without us showing it to them. So showing is really important of this business right now. We cannot sell anything without showing anymore. And what about, so this demonstration problem is really a question about what to demo and to whom to demo. And for the whom question, it would be really nice if we had like an end-to-end demonstration, like with the end customers who will in the end buy the vehicle. And this is really hard with those complex systems because you just cannot give away 100 cars to random people on the street and ask them to crash it for you. So you cannot really do this. What we can do, and we often do this, is we show it to our management. We get some people from our high management and ask them to, okay, please drive around the vehicle and give us feedback. And they can give us great feedback. And once they say, okay, you can go to the customer, we can bring our solutions to the customer. And they will then, we can show it to them and get some feedback. But what do them offer them? If we have already working contracts with our customers, it's quite easy because we just integrate our solution into their system and bring it to them, and they can see something that is very close to their end product. But here, if we don't have a contract already, we should demo something. And for Continental, it's quite easy because, as I said, we have all the different components that is needed. And here, what we did, we built up our own test vehicle with the infrastructure that is needed for automated driving, like all the sensors and computers in the trunk. We have a system integration team who can drive around the vehicle, who can also flash anything on the car, who can give us feedback about how it behaved. And we ourselves have this reference system to demonstrate. But demoing is a really tricky thing because it can lead you into some traps. And here I will explain you one famous trap. This is when Peter, the engineer here, knows that something that he develops will be used only for demo. It means it's hacky time, right? So they will hack some things together, which maybe only works on the test track, maybe it doesn't have all the built-in quality that is needed, maybe he skipped some important processes. But we have something that is working nicely on a test track. And what happens after, he gives it to Bob, who's a sales guy, and he will do what sales guys do, he will try to sell it. So he will tell the customer, okay, hey customer, here's a great solution, it works, please buy it. And it can happen that the customer believes it. So when the customer believes it, she will pay money for it, and we will have a strict deadline, like the start of production, and for this moment you have to be ready with the solution. And the hands are shaken, everybody's happy. What do you think? What would happen like 4 months later? Okay, yeah, I don't know. Probably it involves some kind of shouting to each other, and it probably also involves Peter looking for a new job. So this is like a very big trap here, and we have a thumb rule how to avoid it. And the thumb rule, show what you make. So if you just experience that you are working something that is solely used for demos, this is a red flag. So you should always show the current status of your development, which is like as it is, it works for some extent, and you should also explain what is the limitations, what is needed to be done, and when can it be ready. And in this kind of transparency will enable you good customer collaboration and communication. And it can happen that you have prototypes, like ideas that you don't know if they work or not. You can also bring it to the customer and ask for feedback, but yeah, then always tell them that these are only prototypes.
Okay, so we have some nice demos, we can sell it to our customers, show it to our customers, but our ultimate goal is in the end that we want to save lives by preventing accidents on the street. How can we do that? It means that this is a safety critical system, so we have many very difficult, very rigid processes. We have ASPICE, we have ASIL, we have ISO 26262. We have to obey all of these in order to make sure that what we are producing is safe. If you have heard about maybe built-in quality, this is one of the core principles of the Lean Agile mindset, and it says that when you are creating something, you have to also make sure that it has a great quality. How can you do that if you have so many processes that you have to take care of? So first thing that we would recommend is really keep everything close to the code. Why is it important? Because if you are writing the test and the documentation, when you have written the code, you might as well still remember what it does and you don't have to do it months and years later. If you want to do a worst practice, then of course, store everything very far away from the code and make sure that you never delete them, so it is really confusing for the new developers. It, of course, never has happened to us, but I have heard that it sometimes happens with people. And another suggestion would be to automate everything. So when you have so many checks that you have to make sure that are fulfilled, you have to make sure that it is easily verifiable by the developers. Otherwise, they will forget about it, they will skip it, or they will just don't care about it. If you have this, then maybe you can build it as part of your CI/CD pipeline, and it is easily checkable for the developers to make sure that everything is in place.
Okay, yeah, just imagine that I'm a really nice guy, and I create a build pipeline, I document everything next to the code, and I have the requirements in Git, and I follow all of these things. How can I build prototypes in this environment?
Great question, Arpi. We also have an answer for that. You are really able to create prototypes even in a safety critical system. What we would recommend for you is to create a really modular system. Why is it important? Because in this case, you can have multiple solutions for the same problem, and you can just exchange them. So when you have a software that is really in the cars on the street, and you want to try out a new algorithm, it is not that obvious. But if you have this modular system, you can maybe just take out the old one and plug and play the new one and just test it, how is it working. It's very important that these modules can exist on different maturity levels. What does maturity level mean? It describes the quality of the given module. So for example, it tells you about the testedness, it tells you about the documentation, how well it is verified and how well it is documented. You have to make sure that when you are having softwares on these different maturity levels, to keep them separately. And if you have them separately, then you can allow your stakeholders and your customers to build their own software version. So for example, if they want to do a demo, if they want to do a proof of concept, they might pick the baby software versions, which are having maybe only 50% of unit test coverage and only some kind of vague documentation. And if you want to go to mass production, then you obviously build the grown-up software, which is already well-tested with 200% of unit test coverage and has all of the requirements linked very well for the test cases. It's also really, really important to document and communicate it well to the customers, because otherwise they might be mistaken and put a baby software in their car, and no one wants to see that happen. And when you want to switch from the baby software to the toddler software or even more, what we would like to recommend to you is always do it incrementally. So communicate it to your developers and also to your customers, and make sure that everybody understands these different levels, and they can make sure that they have the best solution for their needs.
So since we are already talking about architecture, because modularity will be a requirement for the architecture. So if we want to develop this way that we can have baby components and major adult components living next to each other, we have to solve it from the architectural point of view. And since I'm the architect, I really like to talk about this. But let's start from the customer. What does the customer want from us from the architecture point of view? And if we are discussing about a solution, they will want to know what comes from us, what is the part that they will provide, and how the system will be built up. So they need some kind of agreement about who does what. So this is something like a task for the architects. Next to it, they will want to have some kind of proof that we know how we will solve the problem. So we have to have some kind of concept that we can already show to them about our solution and how it will solve all the requirements for automated driving. And also, since this is always a collaboration between suppliers and the car manufacturers, we have to have some kind of agreement about integration. So what do we deliver? Do we deliver binary? Do we deliver code? And how we work together? So this is also something that is an input for the architecture.
Okay, but how do you prevent it from turning into waterfall again?
Okay, yeah, the key thing about it is you have to have some architecture done in advance before starting the development. But one thing that you shouldn't really do is to plan everything, design everything up front, and then later on ask the development team to just deliver the solution. Because in this case, we are back at waterfall. And I will show you a great example how to know how many architecture should be done. But first, you have to do some architecture. And the first thing that you want to collect when you're working on architecture is the main behaviors of the system. So what is expected from us? What are our main features, for example? If our solution does automated parking, will it do emergency braking on people as well or not? And we have to somehow describe how our system will work. We also have to do some kind of problem breakdown, because we want to provide an idea how we will solve the problem. And from this problem breakdown, we can define components, like the main components and their interactions within the system. For example, we could have a component for sensing and a component for acting. This is an example problem breakdown, and it can help you defining your teams. And later on, we will talk about teams as well. Third thing is the cost-cutting concerns. It is everything that belongs to or affects all the development. For example, which operating systems are supported, how you build your solution, how you deliver your solution, what kind of testing is needed for everything. And if you have all these figured out, at least for some amount, you can start the development. And here comes the best practice about how much architecture is needed. It's really, really simple. So, JEDI, just enough design initially. It means that if you have an urge, so usually as an architect, I have the urge to decide everything, so everything is solved and it feels like progress. But if you decide things too early, it means that you are just closing options for you. And if you have less options, you have less freedom to move later on. So it is really not a good idea to try to decide on stuff in advance, because that's just limiting you. And here the really tricky part is the E letter. What is enough? Okay, you have to have a feeling about it. You don't have a really easy rule for that. But if you keep this, you can make the important decisions in time. And if you have the decisions, what to do with them? It is, if you don't communicate your decisions, then these are not decisions. These are just your wishes. And you have to communicate to these at least to two different kind of people. So to the business people, you have to tell the constraints of the system. So what are the things that it couldn't really do? Because they will, in this case, not sell things that you cannot do. And you also have to explain the options. So what is still open? What can be reached with this solution? And if you give this to your business people, they will become competent management. And I guess you would like to work with competent management. So this is a really key point. And with the developer teams, so developers will sit in teams, and what you have to really communicate to them is the big picture. So they should really know their team's location in the whole software. What is their task of it? What is not their task? And the team scope is really important. So they should feel comfortable within their own team, and they should have some insight on the big picture. And if you do this, you will have enabled teams. And here, one short question. Do we have anybody here from Disney? Yeah, I hope not. Okay, for the undercover Disney lawyers, this is not a Mickey Mouse. This is an enabled team. And the enabled team will give you two really cool perks. The first thing, they will fix things on their own. This is really, really good thing. So if they see a problem within their own scope, and they have an idea how to solve this problem, they will do it without creating waves of escalation and going to the architect, going to the management. They can act really quickly, they can deliver a quick solution, and it really helps. It really keeps the train rolling. Besides that, they will have great ideas. So if they understand the big picture, they understand then their own part of it, they can come up with ideas which can make our life much easier, and they could open doors for new business opportunities. But all these ideas are limited or often limited to the team scope. So you, as the architect, have to somehow balance with the ideas coming from the team and the ideas or things that are coming from top to the bottom, like the intentional part of the architecture. And if you do it right, you can really work with those teams. I have an example. So here we have the wheel stoppers. These can be found in parking slots usually. And the wheel stoppers, in Japan, there's a rule that if you have wheel stoppers in your parking slot, you have to touch them at least with one of the wheels. If you don't touch it, then they can fine you, the police can fine you for this. So this is really important to solve this. We had an issue that our car didn't really stop at the wheel stopper. So they went over it, they stopped in front of it, but it didn't really stop exactly there. So from two of our teams, we have ideas. First team said, the perception team, okay, just assume that the wheel stopper is perpendicular to the parking slot, build it into our model, and then we can have better predictions of the wheel stoppers. Okay, yeah, it could work. The motion control team had another idea from their own scope, which means that, okay, just go very slowly, and if we see that the wheels are getting stopped, there's the wheel stopper. It sounds really, really trivial, and it is in fact trivial. So we, the architects or the management of this project, had to choose between those two, and we said, okay, implement this second first because it looks easy, and if it didn't work, we can just continue with the other idea. But here you could see we had the enabled teams, we had the ideas from the teams, and then we had to balance between the ideas.
How can you create such enabled teams? So have you ever heard of Conway's law, maybe? Hands up. Some of you, great. So Conway's law says that the structure of the software will somehow mirror the structure of the organization that is creating it. So for example, if you have these small distributed teams, then your software will look also like a small distributed teams. It will have small modules, and it will be a service-oriented architecture. If you have a huge team with difficult relationships, then your software will also look like that. So you will have a monolithic architecture with many, many connections, that this is really not a robust system. What we want to achieve is the first one, the modular software with the small distributed teams. But now we have to decide, how do you want to create the composition of this team? If you have an ADAS system, this will look somehow like this. You will have components for that. For example, sensing, planning, and actuation, which is building up this whole system. And of course, you will have system functionalities such as emergency brake assist or adaptive cruise control. In order for these features to work, you will need the components to work together, to interact together, and to enable the performance of these system features or system functionalities. So now you have two ways to go. Let's have an example. So for example, you have this system with 8 components, and the most obvious choice is to go with so-called component teams. You have 8 teams, and each team focuses on a given component of the system. Why is it good? Because in this case, you will have highly skilled specialists who can focus on one component and create the best possible algorithm for that component. And also, it will make your architecture really clean, because there are no strange relationships between the components and the teams. But maybe you can ask yourself, how can you achieve performance for the system features that you are, in fact, selling to your customers? There's another solution for that called feature teams. So in this case, you are creating teams dedicated for that given system functionality, for example, the emergency brake assist, as I have mentioned, and you have a lot of different people building up this team. In this case, these teams can really focus on that given feature that they are assigned to, but if you can, as you can see, they might mess up the architecture a bit. So which one to choose? Both of them has its perks and also its issues. Unfortunately, we cannot tell you a golden rule today, but I can show you how we are doing it right now. So as we have mentioned earlier, we are working in a so-called base team. Our goal is to create a generalized solution for all kinds of sensor fusion issues, and then we want to deliver it to the application and the customer teams. The application teams has to specialize it to a given sensor set or a given control unit or something like that, and then the customers will take over from the application teams and do the final touches for their given customers. What we have right now is we have component teams in the base part. So we are really focusing on the best possible algorithms, and we are really focusing on keeping the architecture clean. And then we ask our application and customer teams to make sure that we can achieve the performance that we have promised to our customers. It is not only important to focus on the composition of the team, but you have to also really focus on the size of these teams. Why is it important? Now let's imagine that our base project is much smaller than our application project. What will happen in this case? Probably you can guess that some kind of issue, because even if you look at this picture, it looks unbalanced. What will happen is the base team is unable to perform in time, unable to deliver in time, so the application teams are starting to create their own solutions, which will lead to two things. One of them is that you will have double work or multiple work on different branches, the same solutions for the same problems, or they will have something even more chaotic where everybody is trying to branch off from the main branch and then try to merge it back together and rebase, and it's just a mess. You want to avoid it at all cases, so please make sure that your project sizes are well thought through. Lastly, we want to show you a best practice for how to design your organization. It's called BAPO, so it's easy to remember and tell your managers about it. What is usually happening when your company starts a new project looks like this. So you have some kind of organization, and then they have some kind of business acquired. They might even do some kind of reorganization, but it is usually not enough.
But as we heard that according to Conway's law, the architecture and the organization are coupled together. So when to discuss architecture, how architecture comes into this?
So it's really important to include architecture and even processes when you are designing your organization. How should it look like? First of all, you should think about your design, you should think about what you want to deliver, and then the next step is to create your architecture. So as Arpi has already explained to you, you have to use the principle Jedi. So don't try to design everything in the beginning. Just do some kind of high-level architecture, and then you can go on to your processes. So for example, if you work in automotive, you might need to have a completely independent quality management team to make sure that what you're delivering is obeying that lots of processes that I have shown you earlier. And when you have this, the final step is to design your organization. So of course, everything is interconnected with everything, so you might need multiple iterations to determine your final organizational setup, but it's really important to keep this flow. So remember these 4 words, BAPO, and you can help your management to design a perfect organization. And if you have that, a final step is to create communities inside of your organization. Make sure that you have community of practices so the developers can share their knowledge, and after all, you can also go to conferences and share your experiences about it. So what we would like to give you as a takeaway is that Agile is a great way for automated driving. You just have to use it wisely.
And if you are working on demos, only show what you make and not something else.
Even safety-critical systems can help you to create prototypes.
And the main role of architecture is communication, and it has to enable the teams in their own roles.
And at the end, design your organization for the project and not vice versa.
And thank you for attention. We will have some time for questions. If you like us, you can friend us on LinkedIn. If you like Continental, you can scan this QR code and apply for a job. But you can also visit us at our booth here. It's at the far side, at that direction. And yeah, thank you very much. And please remember, Agile is the way for automotive. Just do it wisely. And question?
Hello. All right. Thank you, Anna. Thank you, Árpád. A very informative talk. So we have the Q&A session now. Remember Slido. This is where you're going to be entering your questions, and we're going to be reading them out loud. You can find that on your app, on your phone, or online as well. And actually, so I like the Jedi reference. So for me, like, confronting fear is the destiny of a Jedi, and we're talking about that, right? Kind of making sure we pave the way for agile development and not fall back into waterfall. So can we have Slido show up in the screen? Well, I could actually load it up here for a second. Excuse me. Can we have the Slido? Slido? Okay. All right. Cool. There we go. All right. So I'm just going to read it out loud for the people out here. How the customer adjusted their behavior about the deadlines. How agile they are. Do they wait? Do they waiting for the software before assemble a car?
So first question. Okay. So can I answer that?
Yes.
Yeah. So I also have this feeling about customers that they usually come with strict deadlines. So they tell you strict deadlines, but they also have a plan B. So what happens is if those deadlines are not reached, so they act like they have a fixed deadline, and usually they have some buffer time after it available. And yet, the second part, you waiting? No. So they are working on software and hardware both at the same time. And they are already building up, and they have a concept how to integrate the cameras, how to put everything to the car. They constantly communicate with all of their suppliers and work on this.
So I guess the main takeaway would be like always continue to have the conversation and communicate about the status of the project, where you are.
Yes.
And as long as you keep doing that, the customers also react, right? Like they kind of help you through the problem.
Yeah, and you should actively update them on your problems, on your issues, so they don't expect something like, okay, tomorrow they will deliver and nothing is arrived.
Exactly. Nothing's worse than just getting a surprise at the end, and it's better to be upfront and communicate as often.
Yes.
All right, we have another question. How do you ensure docs are close to the code?
So basically, we are writing the documentation next to the code. So for example, if you have a header file, you are writing the documentation before that, and then we are generating it based on those macros that we are using inside of the code.
So for example, Doxygen is an industry standard now, how to document your code. Also, there are text-based solutions for architecture as well. For example, Plant UML is something that can also be used.
Got it. Does it mean you reshuffle the Scrum teams after each project delivery to find the right structure? That's an interesting one. It's a very
Yes, it's an
interesting
interesting question. So what you have to keep in mind that these projects are usually taking 5 years or 10 years. So yes, it can happen that we need to reshuffle the teams, but we are trying to keep them in their original environment.
Got it, got it. How is the term Agile involved? How the teams burn down their tasks?
Many questions at once.
Yeah. So let's start with the first one. How is the term Agile involved?
How is the term Agile involved?
Yeah, so how is this all interconnected with Agile, I guess, is another way to put it.
Okay, so what we had is a big Agile transformation, as it usually happens to multinational companies. We have started to get into it, and then we are slowly transforming into the Agile way of working. So the team lead mentality is always a challenge. We started to do trainings with them. We started to have Agile coaches inside of the company, and we are trying to slowly transform it into a way where we can really work Agile. And how the design develops, maybe?
Yeah, for design, we try to do it in an agile way. So we don't design too many things up front, as I explained, but we want to iteratively improve on our current design in each iteration. For example, bring in a new feature, bring in a new something, and constantly review our decisions. And the design usually, yeah, we have to document the design in the classical tools like Rhapsody or something like that, but we also have a version that is easily communicated to everyone.
Maybe one last thing about how the teams burn down their tasks. We are working in SAFe. This stands for Scaled Agile Framework. So we are working in big iterations together, and they are also working in sprints like any other Agile team that you can imagine.
Perfect. And the next one is, well, you got jobs, so how do new hires get into the teams?
So when we have new hires, usually we assign them to a team where there's need for people, okay, the trivial part, but I think it's more important that once we have new hires on board, we have an onboarding phase. It means that they don't really have to deliver in the first couple of months. They have to learn how we work. They have to learn the systems and learn everything. So we give time for them, and also there's some kind of freedom between the teams. So if somebody thinks that, okay, I'm more interested in that something else, we can always think about the individual development of the people.
Got it. Being more agile means also that there are enabled teams doing shorter iterations. So joining somebody new, they can just pick up the next iteration. So you're picking up knowledge as you build and as you ship, and then you get kind of that feedback loops going.
Exactly.
Cool. What about agile testing?
Agile testing. Okay, for testing, it is really similar than the development, right? That you can really test iteratively. You can introduce even stricter tests iteratively. You could really raise the level of tests needed. Was this the question? Did it answer your question?
Well, if you want, maybe stay behind, and then you can get a more.
Or you can ask us also later.
Exactly. Yeah. All right, and then maybe one last question before we head on to lunch. How does the process of stepping maturity level for a module look like? To what degree is it automated?
Okay, so it can look like that you have a very low maturity level. It have, for example, 50% of unit test coverage, and then you know that the next step is to achieve 100%. And then the developers can plan it for their next iteration to make sure that they can achieve it. And about the testing, so yes, we are trying to keep everything automated. For example, we have checks for the unit test coverage, we have checks for the static code analysis and everything like that. So most of these checks are automated for us, I would say.
Amazing. Well, thanks again, Anna and Árpád. Can you please show a little love for them today? Thank you for sharing your Agile ways of working.